Every morning it rises, warm, familiar, silent, the most constant thing in the sky. But the sun is not calm, and it is not, in any sense of the word, safe. Right now, its surface is tearing itself apart. Eruptions taller than the entire Earth are exploding outward and collapsing within hours. And yet, the violence you can see is not even the strangest thing about our star, because the sun is breaking one of the most fundamental rules in physics. The surface burns at around 10,000 degrees Fahrenheit, but the atmosphere sitting directly above it reaches 3.5 million Fahrenheit. Heat is supposed to fall as you move away from its source. The sun does the opposite. The corona, its vast outer atmosphere, is more than 300 times hotter than the surface beneath it. And after decades of study, no one has fully explained why. The sun is strange in ways we are still trying to understand. And to understand it at all, you have to go inward to the core. Every second, it converts 600 million tons of hydrogen into helium. The energy this releases is so violent that it takes light 100,000 years to fight its way from the core to the surface. The warmth you feel on your face on a summer morning is 100,000 years old, and it arrived here as the survivor of an almost unimaginable violence. And the sun does not keep that violence to itself, because the corona is not sitting still. It is constantly expanding outward, a stream of charged particles flooding the solar system at hundreds of miles per second. We call it the solar wind. But sometimes the sun does something far more dramatic than breathe. Sometimes it erupts. Deep within its magnetic field, vast loops of energy become tangled and unstable, coiling tighter and tighter until the tension releases in a single catastrophic explosion, a coronal mass ejection. Billions of tons of magnetized plasma launched into space at millions of miles per hour. Not a breeze, a wall, large enough to swallow planets, fast enough to cross the distance between the sun and Earth in as little as 15 hours. And Earth is directly in the firing line. You have to see what happens when that wave arrives. You just never knew what you were looking at. The aurora, those curtains of green and violet light above the poles, are not magic. They are Earth absorbing a hit. Charged particles slam into the upper atmosphere, colliding with oxygen and nitrogen, and the light you see is the energy released by those collisions. It is radiation being converted into color. Beautiful, but a reminder that something out there is constantly pushing against us. And the only reason that push has never killed everything on this planet is a shield we cannot see. Earth's magnetic field, the magnetosphere, wraps around the planet like an invisible shell, deflecting the solar wind and bending charged particles away from the surface. Without it, that radiation would strip our atmosphere away over millions of years. We know this because we have watched it happen to another world. Mars once had a magnetic field. Then it faded. And without that shield, the solar wind slowly, relentlessly tore the Martian atmosphere away into space. What was once a world with liquid water became the cold, irradiated desert we see today. The difference between Earth and Mars is not location. It is that invisible shield. And that shield is not fixed. Earth's magnetic North Pole has drifted for as long as we have tracked it. But in recent decades, it has moved in ways scientists have never recorded before, racing across the Arctic towards Siberia. The field shifts, it weakens in places. It has reversed entirely many times in Earth's past. It is not a wall, it is a living, moving, imperfect thing. And we have already seen what happens when a solar storm arrives powerful enough to test it. It was September the 1st, 1859. British astronomer Richard Carrington was sketching sunspots through his telescope when he witnessed something no human has ever documented. A sudden, intense white flash erupting from the surface of the sun. He was watching a solar flare in real time, one of the most powerful ever recorded. 17 hours later, the eruption it launched arrived at Earth. What followed was unlike anything in recorded history. Telegraph systems across Europe and North America failed simultaneously. Operators received electrical shocks through their equipment. Some lines kept transmitting even after being disconnected from their power, charged by the energy pouring through the atmosphere itself. Papers on desks caught fire. Auroras lit the sky so far south that people near the equator thought cities were burning on the horizon. In the Rocky Mountains, gold miners woke in the middle of the night, convinced it was dawn. The Carrington event was not a near miss. It was a direct hit. And in 1859, the most advanced technology we had was the telegraph wire. Now, consider what that same storm would do today. Satellites blinded, GPS gone dark across the entire planet. Power grids, essentially enormous antennas, overwhelmed by induced currents and collapsing across whole continents. The global supply chain, which runs entirely on digital systems, stopping within hours. A 2013 study commissioned by Lloyd's of London estimated that a Carrington-level event today could leave up to 40 million Americans without power for months, not days, at a cost of up to $2.6 trillion. And this was not a once-in-a-billion-years anomaly. Storms powerful enough to cause real damage have struck at least twice more in the last 2 centuries, in 1921 and again in 1989, when a single storm collapsed the entire power grid of Quebec in 19 seconds. In July 2012, a coronal mass ejection of Carrington-level magnitude erupted from the sun. It missed Earth by 9 days. We are living through the most active years of solar cycle 25, a cycle that has already proven far stronger than scientists predicted. The sun is not dormant. It is at its most active in over a decade. And the question every space weather scientist quietly carries is not whether a Carrington-level event will happen again. It is whether we will have enough warning when it does. Every morning, the sun rises, warm, familiar, patient. It has been here since before the first ocean formed on this planet. It will be here long after the last one evaporates. We do not live under a friendly star. We live under a patient one, and there is the difference. Subscribe to Curio and explore the universe with us.